All right then. So, hi everyone. Welcome to the first in our series of webinars on wildfires. My name's Madeline. I'm the Senior Coordinator for Education here at Forest Canada. Um, I'm going to start my presentation now. Oops. So with this series, you don't need to have For this series, you don't need to see all of them. They are all going to be standalone presentations just on different topics related to wildfire. If you happen to miss one of them, please don't worry. You will be able to pick up what the presentations are talking about later on. So this is just an overview of what the series is going to look like. So today we're talking about what is a wildfire. So we're looking at how wildfires happen, what forest fuels are, and forest fires in recent history, as well as fires in a changing climate. Next week, we'll be looking at wildfire recovery. So the impacts after a wildfire and just natural succession and restoration after a wildfire. And then in 2 weeks, we'll be looking at wildfire management. So looking ahead to future fire seasons. So the history of fire management, Indigenous fire stewardship, and then prescribed burns, wildfire mitigation, and overall forest management. As mentioned, today we're talking about what a wildfire is. So, bit of an introduction if you're not familiar with us. I mentioned I work for Forest Canada. We are a not-for-profit organization dedicated to promoting diverse, resilient, thriving forests today and for future generations. If you'd like more information on us, please feel free to visit our website. But just some fun facts about Forest Canada. We've planted over 50 million trees since 2004. And we have helped collect and manage more than 200 million viable seeds to ensure trees are available for future planting projects. So let's get started. What is a wildfire? I'm going to hide my instruction bar and then look at this. So a wildfire is a fire that happens in the wild and burns natural fuels like trees, shrubs, and grass. For this presentation, we're going to focus on forest fires, but please know that all forest fires are wildfires, but not all wildfires are forest fires. So forest fires and grassland fires are both different types of wildfires. So now that we know what it is, how do they happen? Let's talk a bit about how fire works. So all fires rely on three things: oxygen, heat, and fuel. With these ingredients mixed together in the right way, a fire occurs. Remove one ingredient, you don't have a fire. First, fire needs oxygen. Oxygen is everywhere, and it makes up about 21% of the air that we breathe. And all living things require it to survive, or all living things on land require it to survive. It is a key ingredient to combustion or burning. And when a fire is smothered by something like a fire extinguisher, foam, or fire blanket, it's removing oxygen from that equation. Next up, we have heat or ignition, something to get the fire started. There's a lot of different things that can start fires. Wildfires are sometimes caused by people who leave campfires unattended, burn debris, or dispose of lit cigarettes or matches carelessly. But the remaining fires are started by lightning strikes. According to National Resources Canada, while just over half of all wildfires are started by humans, about 67% of the land burned by wildfires is caused by lightning strikes. This is because fires caused by lightning often occur in more remote areas and can be more difficult to suppress. And then last but certainly not least, we have fuel. Fuel is what the fire will consume once it gets started. You're always going to have oxygen in the air, and you may have a source of heat or ignition, like a bolt of lightning, but that lightning will do nothing without fuel to consume. Fuels in a natural area are limited to plants, for the most part, living or dead. When a fire is starting out, these fuels need to be dry, which must happen before a fuel undergoes combustion and starts to burn. As a fire continues to burn, it will generate more heat, which will in turn make more fuel available to the fire, even if it's wet, dead plant matter, or even a living plant that is full of water. Which type of fuel do you think is easiest to burn? So here we have four options. We have leaf litter, living grass, dead standing trees, or living trees. And if we look at the answers, leaf litter is the easiest to burn. Dead standing trees are harder to burn, but not by not by an incredible amount. But imagine building a campfire. You want to have that small stuff first. You're not going to burn a log right from the jump when you're first getting a fire going. It takes a little bit, but you can always burn a leaf right at the beginning. So, forests are full of plants, young and old, living and dead, which means that there can be a wide variety of fuels available to potential fires. So generally, these are split into three different layers. We have our ground fuels, which are on the ground, deep down in there. We've got surface fuels, which are on the surface of the ground, and then crown fuels, which are big and tall and over our heads. This photo here shows an assortment of surface fuels, namely things like leaf litter or dead leaves on the forest floor and fallen branches. So starting from the bottom up, first we have duff and roots as part of our ground fuel layer. So litter, what we saw in the last slide, is the big stuff you're going to see on the forest floor. Twigs, sticks, full intact leaves and needles, and so on. The litter has not yet started to decompose. That's sitting on the surface. Duff, on the other hand, is the darker, partially decomposed layer under the litter, where any woody material, leaves, and other things in the forest have started to break down and decay. One of the big differences between ground and surface fuels is that ground fuels are often more moist. They will hold on to water better because they are buried under layers of litter, or in the case of roots, soil. Litter, on the other hand, looking at surface fuels, is one of the first things to ignite, and it's one of the easiest fuels to catch fire. As a fire in this layer starts to build, it can get hot enough to start consuming other surface fuels. Things like grasses, shrubs, dead branches, logs, and anything else on that forest floor. Looking at the photo in this slide, we can see a lot of potential fuel on that forest floor. And then from surface fuels, a fire can eventually spread to crown fuels, or fuels found in the crown or higher parts of the forest. Do you know how hot it can get sitting in front of a campfire, fireplace, or wood-burning stove? That radiating heat heats things up around a fire, but are not directly in the fire. Looking at the diagram on this slide, you can see that this radiating heat can preheat and dry out other nearby fuels. The longer something is exposed to heat in this way, the more likely it is to become a fuel itself. Additionally, hot air rises in a process called convection, and it's how fire can climb very easily. This is one of the ways that fire can spread from the forest floor up into the canopy and the branches above. So, I have another word cloud for us. What do you think is fuel in a forest? I will accept multiple answers in this section. So if you have a great idea, you say it first. And then if you have like 10 more ideas, you can also say those, and they'll all pop up. So we're talking about fuel in the forest. What do you think is being lit on fire in a forest, or can be lit on fire in a forest? Ooh, we're getting lots of good answers. So dead plants and trees, dead leaves, dead standing trees, dead things, everything, bark, twigs. Me, oh no. The forest. Uh, All right, submissions are closed. Look at that. Look at our lovely little word cloud of fuels in the forest. All right, so with how fire spreads, you must be thinking, how do forests survive after a fire? Well, they survive by adapting. The boreal forest of Canada covers about 60% of the country, from Yukon and northern BC all the way out to Newfoundland and Labrador. And it's an ecosystem shaped by fire. Forest fires are not new to the landscape in the boreal. Many plants and animals are well adapted to and benefit from fire, and some of them even depend on it. For example, jack pine cones, which I have a picture of on the slide here, are serotinous, which is a big word. It basically means that these cones only open and spread their seeds under extreme heat. So in order to get new jack pine in a forest, you need heat to basically cook these cones and pop them open. Without fire, we aren't getting any more jack pine. Fires can also break up landscapes and create unevenly aged sections in a forest, which encourages biodiversity and allows for a wide range of habitats to live in and around trees of varying ages. Fires that kill off trees allow for sun-loving species or pioneer species to grow and flourish on these damaged landscapes in places where some of these plants might not otherwise fit in a closed, shady environment like a forest usually is. These sunny patches are important for small flowering plants, grasses, birds, and so on. But with this all being said, recent fires have been so severe, intense, and widespread that they're disrupting this natural disturbance cycle. So, in recent history, when we look at forest fires, we do have to look at the fire triangle once again. So, oxygen, heat, and fuel are all key components to a fire, but as a fire persists, other factors must be taken into consideration. Wildfire spread is impacted by topography, or the shape of the landscape on which the fire is happening, and the weather in the area of a fire. So topography is incredibly important for fires because heat rises. So we saw that before with crown fuels, where there's convection and there's heat radiating out and hot air going up. But landscape is also really important for this. Fires can spread 9 times faster uphill than they do on flat ground due to how heat and flames rise. So with this in mind, you don't want a fire to start at the bottom of a hill because that will grow much faster than a fire at, let's say, the top of a hill or on a flat piece of ground. Weather also plays a really important role. So water can suppress a fire by making it harder to burn fuel, and wind can push heat and flames to spread faster. Both precipitation and wind, factors of weather, can impact the spread of a fire. When we talk about weather, we are talking about what you can measure day to day, and it's what you're getting from the atmosphere on sort of a daily basis. But the local pattern of weather, the climate, is also really important for fires as well. It represents what you can expect the average weather to be in an area. So we have another fun little quiz. This is going to be relatively quick, but I'm going to ask you whether you think something is weather or climate. So first, we are looking at average snow cover. Is average snow cover climate or weather? All right. Average snow cover is climate. All right. Now we look at rainfall in millimeters. Is rainfall in millimeters weather or climate? So this is a specific measurement of rainfall. All right. And the majority has it. It is weather. Our next question, humid summers. Are humid summers climate or weather? All right. And once again, you guys are really good at this. Humid summers are, in fact, climate. We have two more. So, minus 25 degrees Celsius. Is this weather or climate? Or minus 25 degrees Celsius wind chill. So, very, very cold wind. Is this weather or climate? All right. Once again, the room has it. It is wind chill. Now, here we have our final question. Is drought weather or climate? Think about what a drought is, right? Is a drought climate or weather? Droughts are, is it a single day? Is it a period of time? Is it an average of something? Drought is technically climate because it is an average decrease in precipitation, right? There's overall less water in an area. But that is how, weather patterns feed into a climate. So, why do weather and climate matter for fire? It's all a matter of fuel availability. So, I did talk a lot about fuels earlier, and I keep coming back to this topic. But the thing is, water is really hard to boil. Water is a very good heat sink, so it's good at absorbing heat, which is why burning wet fuel, whether the fuel is wet because of rain or it's wet because it's, living plant tissue, burning this requires more heat. Usually, when we think of atmospheric water or water coming down from the sky, we want to think rain, but snow melt is very important to the overall moisture in a forest. As snow melts, it provides a slow, prolonged source of water that can seep into the ground and moisten those lower levels of soil, ensuring that the litter and the duff layers are wet for a longer period of time. This is not only good for providing water to all the plant roots in the soil, but it also ensures these historically drier parts of the forest don't catch fire as easily. If you get the same amount of water as rain, it would wash away like storm water, right? But melting snow provides a very slow drip of water that can seep into the ground more effectively. However, in recent history, there has been an overall decrease in snow cover across Canada. So, Canada's a snowy country. About 65% of Canada's landmass has annual snow cover for more than 6 months of the year. Snow is a key part of the hydrological system in the majority of Canada's landscapes, and any changes to it can lead to dramatic side effects. So, I have a graph up on the slide here. And looking at this graph, we can see the extent of snow cover in Canada in April, May, and June. Now we're going to look at the May line, so that purple line in the middle, and you'll notice that it ends at 2023. And in 2023 is the lowest recorded amount of snow cover in Canada at the point of measuring. Now, remembering the year 2023, let's look at this graph where the blue bars show the total area burned by wildfires across Canada. The largest bar, that second last bar, is 2023. 2023 was a record-breaking year for fires in Canada, with 2025 hot on its heels. So the map I have here on the slide is from September 5th, 2023. So we're just going to talk about 2023 right now. In that year, over 6,000 fires torched about 15 million hectares of land. That's a larger area than the entire country of England. This doubled the previous burned area record in Canada, set about 40 years prior. Looking at this map, we can see a snapshot of what parts of Canada were on fire as of September 25th, 2023, just a few months after that snow cover graph. This map only looks at active fires in September and doesn't account for fires that occurred in the spring or summer. So the dots are active fires, and they are different colors, where red dots are current active out of control fires, yellow dots are those being held in place, and blue dots are fires being kept under control. Now you'll notice underneath the dots, there is sort of a colored motley of landscapes. Um, those colors show fire danger or a sense of how easy it is to light nearby plants on fire, how hard it might be to control a fire if one happens, and how much damage a fire might do. You can see that these colored patches on the map range from blue, which is, a low level of risk where fires are likely to extinguish themselves, all the way up to red, which is an extreme risk where you might get fast spreading, high intensity crown fires that are really hard to control. It looks really different on a map, but you might be familiar with these colors related to fire in a different way. So these signs showing forest fire hazard or severity, well, generally forest fire hazard, are very commonly seen on the side of the road. And they're based off the most recent available data on local fire danger or fire hazard. So you'll see them all across Canada, and they indicate what the local risk of fire is and what that might mean for your own activities out in nature. When the risk is high, fire bans might be put in place. Now here's a quick little question. Multiple answers are allowed here. What color on that chart might lead to a fire ban? So you can pick multiple choices. Don't worry if you only select one, that's okay. But what colors between blue, green, yellow, orange, red might indicate there is a local fire ban or a local ban on having campfires or things like that. So generally, some of these graphs will have four or five colors. Sometimes they're missing orange, sometimes they're missing blue. Red and orange typically will indicate a total fire ban, and then sometimes yellow will be like a partial fire ban, right? Sometimes you can burn stuff at night, but not during the day. It depends on your area. Every county, region, municipality might use these charts a bit differently, so it is important to know what it means for you locally. So I've talked about climate change sort of in passing when it relates to fire, but as a whole, Canada is warming at twice the average global rate, and our climate is broadly becoming warmer and drier. This is leading to more frequent and severe conditions that can lead to more frequent, severe, and widespread wildfires. So drier temperature or drier climates, no, drier everything, less precipitation, less humidity, higher heat. All of this is leading to an increased fire hazard or fire danger. Additionally, going hand in hand with climate change is an increase in extreme weather events. These can influence fire danger by either increasing the availability of fuel. So things like low precipitation, droughts, heat waves, or even tornadoes killing a lot of trees and knocking a lot of trees down makes fuel more available to potential fires. And we are also seeing an increase in thunderstorms, which is leading to an increase in points of ignition for potential fires. So, looking at all that, you might be thinking to yourself, well, after the ashes settle, what happens after a wildfire? If those are things you're curious in learning about, please join us next week for the sequel to this webinar, where we will talk about the impacts of wildfire on the environment, society, and economy. And we'll talk about wildfire recovery, both natural succession and human-led restoration efforts. I would like to say a big thank you for joining us today and participating in our webinar. We really appreciate you coming out, taking the time, learning a little bit about how fire works. If you would like more resources or articles, things to read, even lesson plans on fire, please feel free to follow this QR code. We will be sharing this with our participant list as well. So if you don't catch it now, don't worry. you will be receiving a link to these resources later. Um, so this is it for the webinar, but we also have a question and answer period. This will be about 15 minutes. I will happily answer any questions you have, but with me, I also have Val, who works for us here at Forest Canada as well, and she is an expert on all things fire.
Hi, Maddie. What a great webinar. That was really fantastic.
Thank you.
I enjoyed that very much.
All right, so we have a bunch of questions here. Um, I'll answer this first question. So what are the main differences between ground, surface, and crown fuels in terms of where they're located? So ground fuels are going to be slightly buried. So they're going to be underneath like the branches and the newly fallen leaves and stuff. So it's in the ground a little bit. Surface fuels are on top. So usually you can see them, but those are the things you're walking through when you're going on hikes. And then crown fuels are what you see over your head in a forest. So tree trunks, the crown or like the foliage all at the top of the tree, those are crown fuels. We've got one here. Are some plants worse for forest fire than others?
Yeah, sure. Some plants, I would use the word, are better adapted to forest fire than others. Maddie had a great example of the jack pine that has those serotinous cones. So it actually needs fire to be able to release the seeds that are within that cone for it to continue to make more jack pine. And other species, as an example, would be white pine. When it gets really big, it has a really thick cambium. The bark gets really thick and is doesn't affect the tree. It in wildfire situations, it's quite adapted to fire. Another species to think about is oak, is another that has that thick bark, thick cambium layer that doesn't make it susceptible to fire.
Yeah. So so basically trees with a really thick bark like your white pine or your red oak, you're not going to get very much. The tree itself will not catch fire because just the bark is like a shield, right?
Right.
Yeah.
How much was control fire burned in 2025? That's a really hard question. I'll just take a few minutes to explain that
Yeah,
a little bit.
absolutely.
So there's kind of two ways to think about controlled fire. One is a prescribed burn, and another is cultural burning. So cultural burning is conducted through First Nation communities who have a long, long history with cultural burning. Um, they wouldn't necessarily be recorded in any kind of way formally on government websites and things like that. So we wouldn't really know how many controlled burns. Other controlled burns wouldn't such as prescribed burning through other types of folks that do, many of them who do that for a living actually, wouldn't be part of like a wildfire number across Canada. They would be contractors hired to do that type of work for a specific purpose. So that's kind of a just a tricky question there. We wouldn't know the number of control fire in 2025.
Yeah. Um, there's one here. Why are all the fires, so on that fire chart that I showed with active fires as of September 2023, why were they all in Yukon and Northwest Territories, even though it's so cold there? That
Well,
would,
that, well,
oh,
that area, even though it's cold for a lot of the time in the year, doesn't mean it still doesn't get hot and dry. which, as Maddie pointed out about the fire triangle, as long as you have those three things, the fire or the oxygen, the fuel, and an ignition source, you can still have a fire. So um, they don't have a lot of trees like they do up there as compared to the south in some regions, but it still can get dry and hot, and the fuels can dry out and still cause a fire.
And one thing I'll note also is that while the air temperature might still be relatively cold, so let's say it's 5 or 10 degrees Celsius, as an example, air temperature stops mattering as much when a fire starts going, because the fire will generate its own heat by burning off that fuel. And so by generating its own heat, it can also build and grow and get other things hotter. So climate and weather are absolutely important. But once that fire starts moving, starts building, it matters a little bit less, what the outside temperature is. Not entirely, like very, very hot summers will cause more fires, but yeah. Average snow cover in Canada in 2026. So I don't know an answer to that question. That is a really good question. I know that that's often a statistic that is recorded by Natural Resources Canada. I don't know the best place to find that information. Usually you get it at the end of the year, looking back. Um, but it's good to look ahead. It's good to see, what this year is going to look like. Um, if anyone here is like me and in Ontario, you know that we have a lot of snow right now, but that might not hold true for the rest of the country. Um, I'm going to say one more question. Um, so first of all, I love that we have a question here about what we can do about wildfires in Canada. That is something I'm talking about in later webinars, just because it is a really big topic. There's a lot of different things we can do. Um, so I really appreciate the question, and we will have answers for you down the line, so don't you worry. So one more question here. How long would it take for a region to adapt to an increase in wildfire frequency? Can a landscape adapt in an increase in wildfire frequency? I don't know.
Well, a lot of these ecosystems that have adapted have done so over millions of years. So I don't really know the answer to that question. It would take a very, very long time.
Yeah, that's what I was thinking. Because with the way ecosystems work, there's a lot of moving parts, right? So you have plants that are used to being in these environments with fire, whether it's, protective bark keeping the tree alive, or it's seeds that only spread after exposure to extreme heat. You have lots of plants that will, leave their seeds in the soil, and ideally in not very hot fires, that soil is relatively undisturbed and the seeds survive. Um, but adapting to extreme heat takes, yeah, millions of years of evolution and adaptation. Um, so there's no quick fix, I guess. Um, and yeah, and then we have a question here. What are the good plants that are fire resistant? Um, the ones that we had mentioned before. So some of those trees that just when they get really big, they have a lot of resistance to fire. Oh, one thing I'll note, broad-leaved trees are generally more fire resistant than conifers. So any tree that has needles on it or scales on it. So think of your pine, your cedar, your fir, your spruce. They are um, generally more flammable. Not exactly, not all the time, but they have less water in them than something like an aspen or a maple or an oak. Um, it's not always true. You can still get fires in broad-leaved trees or deciduous trees, but it's just a matter of sort of where they grow and what habitats those trees prefer living in. I just think about fire indices and how, like, when you have a poplar aspen forest, it's really hard to burn them. Um, so yeah, that's the only answer I can give you, Gary. I'm so sorry. I don't have a better one. I don't know if you have a better one, Val.
No, that's right. Some plants can adapt better than others, and you answered it really well. It's complicated.
It's very complicated, unfortunately.
Nature is complicated.
Yeah. So I think that's it for our questions. We have one question pending moderation, but I don't know if it'll come through. So I want to thank everyone again for coming out. I really appreciate all of the time you've spent on this. If you have any further questions, you are welcome to reach out to us via email. So the best way to reach me is at education@forestcanada.ca. We'd be happy to answer any questions you might have. And again, if you'd like access to more resources or articles on forest fires or even some lesson plans, please feel free to follow the QR code on screen. I appreciate your time and I hope you have a lovely rest of your day.